Okay, if we're trying to solve this quadratic, then we can chuck it into the formula to get x equals minus b, minus 5 is plus 5, plus or minus the square root of b squared minus 4ac, which is 4 times 1 times 6, 24, all over 2a. And that gives us, well, the square root of 1 is just 1, so it's 5 plus 1 over 2, or 5 minus 1 over 2. 5 plus 1 over 2 is 6 over 2. 5 minus 1 over 2 is 4 over 2, so the answers are 3 and 2 there. And I think we agreed with that. If we were to draw a graph of that, it would cross at 2 and at 3. Those are the roots, and it would look like that. Okay, I've drawn that terribly. You might be able to figure out what that point is if you thought about what we did when we sat at the computers. Anyone?
You just plug it in. 6.
So it's 6, because if you chuck 0 into this equation, you get 0 squared minus 5 times 0 plus 6. So it must have a value of 6 at this point, not 0. So that's the y-intercept, just like it was for y equals mx plus c. Now, moving on to another one, if we look at the second one, x squared plus 6x plus 9 equals 0. Then again, I'm going to use the formula to solve this. I could factorise, but I'm not going to do that. I'm going to use the formula. X equals minus b plus or minus the square root of b squared minus 4 times 1 times 9 divided by 2a. And that gives me minus 6 plus root 0, which is minus 6 over 2. And minus 6 minus root 0, which is minus 6 over 2. So I appear to get the same solution twice. And the only thing that can happen with the graph of that is that it's just hitting minus 3 and then going up again. Anyone? That point there?
9. 1 real root.
Yeah, 9. And we claim that this, we then conclude that this has one root, or one real root, as we'll usually say. Sounds odd to say that just at the minute. What about x squared add 2x add 8 equals 0? Well, in this case, chuck it into the formula, x equals minus b plus or minus the square root of b squared minus 4ac. 4ac is 4 times 1 times 8. So we end up with the square root of minus 28 there. And there's the problem. You cannot get a square root of a negative. This has no solutions. At this point already, I know that this thing here has no solution. Forget about, if you do further maths, just forget about what you've been learning in the last lesson or so. But it certainly has no real roots, and I think we're all going to agree with that, whatever real means. It just means a normal number. It has no normal roots. If it has any solution, it's not a number that we're aware of. And we'll leave it like that. The graph of this, well, I know it's going to go through 8 because of that bit. So I know it's going to go through 8 here. But apart from that, I don't know much about it at all. So it could look like this. I know it doesn't hit the axes, otherwise it would have solutions. So it might be like that. I'd need to think a bit harder about where that vertex was. So I might have got that completely wrong. Now, I want us to look back at these 3 types. This first type had 2 solutions. Here they are, 2 solutions. And the 2 solutions came from this bit. One where you add, one where you subtract. Agreed? So if we added 1, we got 1 solution. If we subtracted 1, we got the other solution, 2 solutions. And it came because this value here had a value which we could work out. We added 1, and then we subtracted 1 in this case. So that number there tells us that we have 2 solutions. Not the fact that it's 1, but the fact that it's a positive number. We could have had the square root of 4 at this point, or the square root of 6. It wouldn't have been so nice, the square root of 6, but it would still have given us 2 answers, one where we add it, one where we subtract it. That's an important thing there in how many solutions there are. The second one had only 1 solution, and the reason was because we either added 0 or subtracted 0. And that's the same thing. So we got the same answer twice. We don't need to write it twice, just understand that it is a repeated root. It's got 1 real root. And the third one, this bit was now negative, and we ended up with not being able to work out an answer. There's no solutions to this. Try any value of x in this, and you will not get this to work out to equal 0. There are no real roots. The thing under the square root is called the discriminant, or something like that spelling, the discriminant. So it's the bit under the square root in the quadratic. Here, the discriminant is minus 28. It's the fact that it's negative which causes problems. So if the discriminant is negative, no real roots. What if the discriminant is 0? If the discriminant is 0, 1 root, repeated, and the graph looks like this. And finally, or really originally, the first one that we did, but the last one I'll talk about, if the discriminant is positive, here it's 1, there are 2 real roots. One we add, one we subtract, and it crosses at both of those. Okay, 2 real roots. The discriminant is a really important thing when it comes to solving quadratic equations. And I'm going to leave you now with a problem. I'm going to think of a quadratic equation. My quadratic equation is x squared add something, I'm not telling you what that something is, times x, add 4 equals 0, but I'm going to give you a clue to find out what k is. And the clue is that this quadratic equation has 1 real root. Can you find the value of k, or maybe even the values of k, which make that equation have 1 real root? Right, we're going to use the clue here. To solve x squared plus kx plus 4 equals 0, it has 1 real root. We're going to use the clue that it has 1 real root. Now, from before, 1 real root, the one which had the same root repeated was this one, and that's when the discriminant was 0. So the clue is that if it's got 1 real root, then the discriminant is 0. That's actually all we need to know to answer this question now. So we form the discriminant, which is b squared, in this case b is k, minus 4ac must equal 0 in this case. It doesn't always equal 0, but if there's 1 real root, it does. So if b squared minus 4ac equals 0, then we end up with k squared equals, in this case, 16. Take it over the other side of 16. And here's where a number of people made a mistake there. Taking a square root, I get k equals 4. But there's another answer which, when you square it, you get 16. It's plus or minus 4. Two different values of k. Okay?